Okay, what we're going to do is do a problem where we find the volume of the solid by subtracting two volumes. I don't know if I'm going to do this by subtracting two volumes. I'm going to look at the region and see if I can figure out how to find the volume. So it's a little bit tricky, but essentially what we have is we have two planes that are some of the boundaries of the region. I'm going to write this first one that comes first as z equals negative x minus y plus 2. And this other one over here, if I just add z to the right-hand side, I'll get z equals 2x plus 2y plus 10. And well, I feel like if I spend a lot of time, I can sketch the graph. But I mean, one way to look at this, this one lies above. This one has plus 10 and this one has plus 2. But one thing we could do is maybe find our region D and then plot some points and see which one's greater. But this, all right, so the idea is not drawing a good picture at all, but I have two planes. Not say they're horizontal planes, but say I have one plane up here, and then I have another plane down here, something like that. Okay, so since it's three-dimensional, it's hard to draw good pictures, but we're trying to find the solid, find the solid region. Now, the thing is that what are the boundaries of our region? That's formed by these guys right here, which I can sketch in the XY plane. So I'm gonna on the side here, I'm gonna sketch the region D in the XY plane. So this is, one of the more advanced problems, but maybe not in a way. Once we set up the integral, I think it should be maybe not so bad at all. So, okay, we have y equals 1 minus x squared, which I don't feel like I'm going to spend a bunch of time on that. It's a downward facing parabola shifted up by 1. And so, that's it. We'll see if that's enough, whether I should keep going with, extending that. But that's roughly it right there. That's the y equals 1 minus x squared. That's the first one. And then y equals x squared minus 1 is going to be an upward facing parabola shifted down by 1. Let's maybe change color here. Okay, so I put that over here, and I think that just by, carefully sketching these two graphs, I can see what the point of intersection is. But this is our region D in the XY plane. And so D is a type 1 region. I say that because there's a top function that bounds it from above, and there's a bottom that bounds it from below. So in terms of review for the test, this is our quiz, sort of starting off with one of the more difficult problems. All right, so that might, in terms of review, that might not be the very best thing to do. But here we have y equals, on the top, 1 minus x squared, and the bottom, y equals x squared minus 1. So it was, it wasn't that hard to sketch those parabolas. I think if you know a bit about parabolas, it's not that difficult. But some regions might be more difficult to draw. But since it's sort of easy, I did that. So this is type 1. And then, so D is bounded, okay, here's xy. So see, it's type 1, meaning there's a top function, y equals 1 minus x squared, and a bottom function, y equals x squared minus 1. So our y values are bounded by those two functions. And then x is bounded between -1 and 1. So I'll write that down first. But then y is between x squared minus 1 on the bottom and 1 minus x squared on the top. So that's a type 2 region, or I'm sorry, type 1 region. And So back to this picture over here, where I have these two planes, let me try to make sense of that by making this into a three-dimensional picture in the XYZ plane. All right, so, okay, so here's X, here's Y, and here's Z. And it's not, I don't think it's that necessary at all to have a really good drawing for this. That's not what the question asked for. But essentially, our region D is sitting down here. As you know, as we can see, it's like this. Well, why don't I just use the same colors just to sort of looks more familiar. So here's the bottom, and here's the top of D. I mean, it almost looks like a, you know, like a disc or something. So that's down here, and then what's going on then is our planes are lying above. But like I said, I'm not going to try to make my planes even close to being, you know, accurate, I guess. But there is an issue of, well, how do I know which one's greater? So I don't think I'm very, on that part, I guess I'm not being precise of knowing which one's greater. I mean, I can see that if I plug in, say, x equals 0, y equals 0, then I can see which one's greater. But that maybe isn't, that's not really a proof that one's lying above the other. But this one on the top should be z equals 2x plus 2y plus 10, and the one on the bottom is equal to z equals negative x minus y plus 2. So, in fact, as we can, if you put in x equals 0, y equals 0, this should be, you know, this should be sitting something like that above there. Okay, so I mean, if I put things in, if x and y are positive, this purple one's certainly above the brown one there.
Did you plug in like boundary points? Like, if you really wanted to know?
That's I mean that yeah that's a really interesting idea. Is that enough? Is enough of a proof? If I were to simply put in the boundary points, and I'd say could be. It's a
Like 1, -1.
right.
Y equals, they're all over.
Well, I mean the thing is the boundary is not a, you know, the boundary is this shape. So let me come back to that and just sort of finish up on this. So see, our region is this type of thing. It looks almost like a cylinder because this looks almost like a disc. So let's just go ahead and do the integral, and then, I don't know, maybe I'll just have to come back to think about how do I know for sure which one's greater. I mean, there might be okay, look. If you take away this 10 and the 2, those two planes are parallel to each other, aren't they? They both. Okay, let me just not spend too much time on that. But okay, so the volume. Sorry, I started thinking two things at the same time. But the volume is going to be a double integral over d of this top region, which is, well, let me just write it like this: fxy minus gxy dA, where this one's on the top and this one's on the bottom. And so the one on the top is, which I haven't proven, but it's 2x plus 2y plus 10. The one on the bottom is negative x minus y plus 2. And then, okay, so dA, well, what's dA? This is a type 1 region. So I integrate with the numbers 1 to 1 last. And then so that's x. X is between -1 and 1. So, and then I put the y values, which is x squared minus 1 and 1 minus x squared. I put those first, and that's dy. So this is -1 to 1 I'm going to simplify this before I integrate. So 2x plus 2y plus 10 plus x plus y minus 2 dy, and then that's going to be dx. So that's 3x plus 3y plus 8 dy and then dx. Okay, here's my little ideas that some people might say, well, why are you doing that? I don't know, I think it's good. Okay, which is this. I'm going to take the 3x and 8. And by the way, I mean, it's good to stop and say, okay, hold on, did I add these up right? 2x plus x, 2y plus y. All right, well, it seems like it's okay. 10 minus 2 is 8. I'm going to take this 3x plus 8 and just put parentheses around that because that's a constant in respect to integrating with respect to y. And then 3y. All right, so I'm sort of stretching that part out, but now I'm going to integrate. I have the constant with respect to y, and that's 3x plus 8. So I'm going to do 3x plus 8 times y, and then I have this y here, and so I'll have 3y squared over 2. And then I'm going to evaluate from x squared minus 1 to 1 minus x squared. And so negative 1 to 1, I have 3x plus 8, and now I evaluate y from x squared minus 1 to 1 minus x squared, plus 3 halves, and I evaluated y squared from x squared minus 1 to 1 minus x squared. Then that's going to be dx. So then I have negative 1 to 1, 3x plus 8, and I'll put in for y 1 minus x squared, and then subtract, put in for y x squared minus 1. So that is going to give us some simplification. And then I have 3 halves, and then I have 1 minus x squared squared minus x squared plus 1 squared. All of this dx. Okay, so let me just write it down here like this, is that this is equal to, this part is equal to 1 minus x squared plus 1. Okay. So this is going to be the integral from negative 1 to 1, 3x plus 8. I can see why you asked this question. It's sort of a lot, right? 2 minus 2x squared plus 3 halves. All right, then, okay, I want to point something out here, which is that 1 minus x squared squared is the same thing as x squared minus 1 squared. So that's going to be 0. So let's just do a little aside. If you have a minus b and you square it, that's the same thing as b minus a squared. Because, okay, I mean, you can just check it out. A squared minus 2ab plus b squared, and this one is b squared minus 2ab plus a squared. I mean, they're the same. And so this part here is equal to 0, isn't it, right? 1 minus x squared is minus 1, they're the same. You can just not do that and just keep rolling away on it, but it makes it a little easier. And so then I do need to use FOIL. Before I do FOIL, I could factor out 2 from this one, from the second factor. Actually, when I take out negative 2, so I don't like doing 2 minus x squared. I want to do x squared minus. So I take out a negative 2 and I get x squared minus 1. And then I'm going to use, it's just things like that that just make it easier for me to multiply, like I'm doing this FOIL business. So I'm going to do the first, the outer, the inner, the last, okay, all that. This FOIL character, all right. So I have 3x cubed minus 3x plus 8x squared minus 8 dx. Any comments about that so far? Okay, I would like to point out that some of those functions are even functions and some of them are odd. If I group the even functions, well, what can I do with that? And I group the odds.
Odds will cancel out, right?
It's from -1 to 1, so this is odd. So this whole thing is equal to 0. And this is even. I mean, you don't have to do that, but another little shortcut here, which I like. So I can take this and multiply by 2 and go from 0 to 1. 8x squared minus 8. How do I know that this is odd? Because it's to an odd power. How do I know it's even? It's the even power, including 8. 8 is x. 8 times x is 0 power. So I get -4, and then I can factor out 8. Let me just write. -2 times 2, I'll factor out 8. And then I have 0 to 1 of x squared minus 1 dx. So -2 times 2 is 4. -4 times 8 is -32. And then I'm going to integrate, and I have x to the third over 3 minus x. And I go from 0 to 1. And when I plug in 0, everything is 0. If I put in 1, put in x as 1, I just replace 1. 1 to the third, 1. Okay. So I have -32, 1/3 minus 1. So it's -32 times -2/3, which is 64 over 3. And then because it's even, and I have this symmetry, so if I go from -1 to 1, it's the same thing as doubling and going from 0 to 1. So let me just point out, let me just do a really simple example of that. Yeah, that's right, it has a 2 there. So let me do a simple example of this. Here is, here's, just single variable case, y equals x squared. Suppose I'm integrating from -1 to 1 x squared dx. So that means this region here, from -1 to 1. But by symmetry, because it's even functions are symmetrical around the origin, we see those regions have the same area. And so this is 2 times 0 to 1 x squared dx, and then you can evaluate that. So it's just, the thing is, we're going to do like a big pile of integration. And for that reason, if there's a little shortcut, then I want to take it. But on the other hand, I don't want to do shortcuts to the point where it's super confusing. So this is 15.2, number 35. And that'd be so awesome to get the right answer. Yes. Okay, what's missing in this problem, which I swept under the rug, is still we want to prove everything is absolutely true in math. We don't want to say, well, I think it's true. How do I know that this guy is above this one so there's no doubt about it? Like I could base, if I'm making an aircraft, I thing's not going to crash because if this is wrong, it's going to crash. So how do I know for sure that that's above? I mean, I'm adding 10, and this one I'm only adding 2. But on the other hand, so it's certainly true if I'm in x and y are positive. But oh my goodness, I think that what you're saying is maybe look at some of these endpoints, but still, is it 100% true? Like if I put if I look at this point here, if x is -1 and y is 0, plug that in there, and then make sure it holds. Put in. Okay. I mean, let's look at this region. So note, x is between 1 and -1. Y is between 1 and -1. So at the very extreme, the maximum this is going to be is when x is -1 and y is -1, and I get, even if that doesn't happen at the same time. But at the most x can be is -1. And the most y can be is -1. So -1 makes 1. -1 makes 1. So that makes 1 plus 1 is 2. So the most this ever could be is 4. But I don't even think it reaches 4 because x and y are never both -1. On the other hand, the very least this one could be is when x is -1, y is -1. And that'll give -2 plus -2 is 10, which is 6. So I think that's my argument for that, and we got the right answer and all that. Okay, so that's my argument, which I think is a decent one for sure, but that was a little tricky. Okay, any last questions?